Hi, my name is Tom Hoeffel, and this channel is all about helping students learn chemistry. In this video, we're going to be talking about polar and nonpolar molecules. Now, in order for a molecule to be nonpolar, all its dipoles have to cancel out. If they do cancel out, okay, we would say that it has a zero dipole moment. And if it has a zero dipole moment, that means that the molecule as a whole is nonpolar. So we have these words polar and nonpolar to discuss bonds, but we also use this word polar and nonpolar to talk about the molecule as a whole. So let's get into the video. If we had something that had two domains, okay, and the non-central atoms were identical, then this dipole would cancel out this dipole because those forces would be equal but in opposite directions, okay? And if the dipoles cancel out, we can say that the molecule is nonpolar. So once again, you could have polar bonds that each have a dipole, but if they cancel each other out due to the symmetry of the molecule, we say that the molecule as a whole is nonpolar. Let's take a look at three domains. Once again, if all of these non-central atoms were identical, due to the symmetry, because of valence shell electron pair repulsion theory, these dipoles would cancel out, okay? So if the dipoles cancel out, remember that's a zero dipole moment for the entire molecule, and we say the molecule is nonpolar. So if there's symmetry within the molecule, then we say that it's nonpolar. When we have a lone pair, it breaks up the symmetry, okay? So this thing is no longer symmetrical. This dipole will not cancel out this dipole because it's not in a linear shape. It's in a bent shape, okay? So if the dipoles do not cancel out, we say that it has a non-zero dipole moment, which means it's some type of number, okay? We don't have to calculate that number. We just know that they don't cancel out, and since they don't cancel out, this molecule bent is going to be polar. If we go up to four domains, and we get this tetrahedral shape, which is symmetrical because of the valence shell electron pair repulsion theory, if all of these non-central atoms are exactly the same, these dipoles will cancel out due to the symmetry of the molecule. So if the molecule has symmetry, all of the polar bonds dipoles end up canceling out, and the molecule as a whole is nonpolar. If I get a lone pair, though, the symmetry is broken up, okay? And if the symmetry is no longer existing, these dipoles don't cancel each other out, the molecule is polar, so trigonal pyramidal will be a polar molecule, as well as bent. There is no symmetry here. The dipoles don't cancel out, and we have a polar molecule. Now, as we get to five domains, okay, remember 5 domains is just a combination of trigonal planar and linear put together. That's kind of how trigonal bipyramidal kind of exists, okay? So there is symmetry along the trigonal planar, and there's some symmetry along the linear piece of it. So if all these non-central atoms are the same, the dipoles will cancel each other out, and this molecule would be nonpolar. If we have one lone pair, though, this breaks up the symmetry. This molecule is polar. So seesaw is polar. T-shaped is polar. The dipoles don't cancel each other out. It's polar. However, if I go all the way to 3 lone pairs, we get our symmetry back with the linear molecule, okay? And this molecule would be nonpolar with 2 bonding domains and 3 lone pairs around the equatorial plane. Okay, so this molecule, once again, would be nonpolar because the dipoles cancel each other out. And then we're going to move on into 6 domains. If you have 6 domains, you have this structure over here, which is called octahedral. It's perfectly symmetrical. So this dipole would cancel this one out, this one would cancel this one out, and this one would cancel this one out. And if all the dipoles cancel out, okay, you have a nonpolar molecule. However, if you have one lone pair, that breaks up the symmetry. It's no longer symmetrical, and this molecule is going to be polar because the dipoles don't cancel out. If you have two lone pairs, though, okay, you do get some symmetry back into the molecule. So square planar, okay, this dipole will cancel out this, and this one will cancel out this. So this is a nonpolar molecule because we got some symmetry back into the molecule. So square planar is nonpolar. Square pyramidal is polar. And octahedral, okay, is nonpolar because all the dipoles cancel out. So when there's no lone pairs and everything's bonding here, all of these molecules here are nonpolar because their dipoles cancel each other out. As soon as you add a lone pair, it may break up the symmetry and you might have a polar molecule, but if you keep taking them off, you might get some symmetry back and make your molecule nonpolar again. So it depends on the geometry. It depends on the symmetry. If you have symmetry, okay, the dipoles will cancel out and the molecule will be nonpolar. If it's asymmetrical or the symmetry is gone, more than likely you're going to have that polar molecule. And if this information was helpful on how you determine if a molecule as a whole is polar or nonpolar, please like and subscribe and watch more of my videos because that helps the YouTube algorithm get this out to more students that are interested in learning chemistry in a straightforward fashion.